This screencast will cover mixed design ANOVA, which is also referred to as repeated measures with a between-subject factor in some textbooks. In this screencast, you will learn how to carry out and interpret a mixed design ANOVA test. You will also learn how to report the results of a mixed design ANOVA test. The dataset we will use for this example lists the body fat percentage scores of 4 independent groups of overweight individuals who participated in an experiment aimed to reduce their body fat percentage. The 4 groups are control, no intervention, diet only, exercise only, and diet and exercise. The participants' body fat percentage was taken on 3 different occasions: at baseline, at the end of the intervention, 6 months, and at 12 months, the follow-up period. This is an example of a mixed design ANOVA with one between-subject factor, group, with 4 levels, and one within-subject factor, time, with 3 levels. The aim of the study was to evaluate whether the participants in the different groups reduced their body fat percentage over time, and whether such a reduction was more salient in some groups than others, i.e., whether there was an interaction between group and time. As you can see in the SPSS data file here, our variables are listed. The first variable, group, refers to the between subjects factor, which group the participants were in. The before, after, and follow-up refers to the different time points that testing occurred. These different time points refer to our within-subject factors. For example, participant 1 was in group 1 and had measurements taken at all 3 time points. The assumptions of a mixed design ANOVA are similar to those of a repeated measures ANOVA and a one-way ANOVA. Please refer to those screencasts. To begin the analysis, click Analyze. Click General Linear Model. Click Repeated Measures. This will open up a new box called Repeated Measures Define Factors. In this box, underneath where it says Within Subject Factor Name, please put time. This represents the different time points. Then where it says Number of Levels, put 3 to represent each of your 3 time points, before, after, and follow-up. Then click Add, and then click Define. This will open up a new box called Repeated Measures. In this box, we will define our within subject factor, each of the time points, and our between subject factor, group. First, move each of your within subject variables across to the within subject variable box. Your within subject variables are the variables that were measured on repeated occasions, the before, after, and follow-up. Simply do this by clicking each variable and then clicking the arrow located in the middle next to the within subjects variable box. Now move your between subjects factor, group, to the between subjects factor box. Do this by clicking on group and then clicking on the arrow located between the box it's currently in and the between subject factors box. Now click Plots. This will now open up a window called Repeated Measures Profile Plots. Since we are interested in the interaction between time and group, it is important that we request a plot of the interaction to aid our interpretation of it. Move time into the horizontal axis box and group into the separate lines box. Usually, you display separate lines for the independent variable with the fewest levels. In this instance, that would be the within subject variable. However, in this case, it makes more sense to request separate lines for group in order to examine how the mean scores of each group change over time. Once you have moved your variables over, then click Add. It is essential to click Add for SPSS to create the plot. Once you have clicked Add, then click Continue. Now click Post Hoc. This will open up the repeated measures post hoc multiple comparisons for observed means box. In this box, we want to click Group, and then click the arrow between the box Factor and Post Hoc Test 4 to move group across. Then select Tukey. This will tell SPSS to run a Tukey post hoc comparison for the 4 groups. Then click Continue. Now click Options. This will now open up a box called Options. In the Estimated Marginal Means box, select Time and Time by Group interaction and move them into the Display Means For box. Tick on Compare Main Effects and select for Confidence Interval Adjustment the Bonferroni method. Finally, under Display, make sure the following boxes are ticked: Descriptives, Estimates of Effect Size, Observed Power, and Homogeneity Tests. Click Continue, and then OK. Now click OK. This has now opened up your SPSS output. As you can see here in the Descriptive Statistics box, this gives the means and standard deviations for each of your groups at each of the time points. If we look at the box that says Before, we can see the means for the control, the diet, the exercise, and the diet and exercise groups, as well as the total for the entire sample of the before means. The current area, outlined in yellow, displays the Mauchly's test of sphericity. To learn more about the Mauchly's test of sphericity, please refer to the screencast on repeated measures ANOVA. In the current example, the assumptions of the test are met because the test is not significant. We know the test is not significant because the significance value, or the p-value, is 0.279. Besides the sphericity assumption, it is useful to show that the variance of body fat scores is equivalent in each group, and that this is the case at each time point. This is examined by the Levene's test of equality of error variances, reported by SPSS on the screen. The F values indicate that none of them is significant and that the assumption is met at each time point. Scroll down to the Tests of Within Subjects Effects box. In this box, we will read from the line sphericity assumed because Mauchly's test suggested that the assumption is met in the data. Let's now focus on the box that says time. We will follow the sphericity assumed line because the Mauchly's test indicated that sphericity was assumed. There's a significant difference in time because the p-value, or the significance value, is less than 0.001. This indicates that there are changes over time in body fat percentage across the whole sample. Now let's look at the time by group box, which tells us about the interaction. The F value is significant in this as well, because P is once again less than 0.001. This indicates that the changes in body fat percentage over time are not equivalent across the 4 groups. In view of the significant interaction, we should ignore the between and within subject effects and concentrate on the interaction between the 2 factors. If the main effect of time by group is not statistically significant, but the main effect for time and/or the main effect for group is significant, you need to examine those further. For the sake of this screencast, even though the time by group interaction is significant, we will go through all steps. Now move down to the box that says Tests of Between Subjects Effects. This box tells us if there are significant differences between the groups, so we follow the line that says group. As you can see here, there is a significant difference because P is less than 0.001, which means that it is less than 0.05, and is statistically significant. This indicates that the group differences in body fat percentage averaged across time are significant. Since the main effect for group and the main effect for time were significantly different, we are going to examine them further. As previously stated, since the group by time interaction was statistically significant, that is the only thing you need to examine further. Now we are going to go through the within subject effect. Scroll further down in the output to find the table which present the estimated marginal means. The estimates table presents the mean body fat percentage for the whole sample at each time point. Looking at this and the means, it seems as if there was a reduction in body fat percentage over time. However, which of these time points differed significantly from the rest? To answer this question, we need to look at the table below, called pairwise comparisons. The current table outlined in yellow is the pairwise comparison table. This shows the body fat percentage for each of the time points against one another. Basically, it compares them and lets us know if they're significantly different from one another. According to these results, body fat percentage reduced significantly from baseline to the end of the study. Now we will interpret the significant between subject effects, which is looking at the differences between the groups. As group has 4 levels, we need to inspect the results of the post-hoc Tukey tests. Further down in the output, you will find the multiple comparisons table in a section entitled Post-hoc Tests. The table compares the body fat percentage in each group averaged across time. Looking at these results, we can tell that the control group had significantly higher body fat percentage than the exercise group and the diet and exercise group. We get this information from looking at the line that says control, and then looking at the diet, and exercise lines that are across from it, and then looking at the p-values that correspond with each of those. So in the control box, the exercise group is significantly different because the p-value is 0.016, which is less than 0.05. The same thing is true for the diet and exercise group, which is p less than 0.001, because again, it is less than 0.05. If we look at the box for the diet and exercise group, we can see that in addition to being significantly different from the control group, the diet and exercise group is also different from the diet group, because p is 0.004, which is less than 0.05. looking at all the other mean comparisons, we can tell that they were not significantly different. Since the interaction between time and group was significant, therefore, we need to interpret it and ignore the significant between and within subject effects. Move right to the end of the output, where you can see a plot of the interaction. We can interpret the plot, but we cannot use the word significant because we have yet to carry out follow-up tests for this interaction. By examining the plot, we can see that the mean scores of all four groups are very similar at baseline. The mean scores for the control group are quite similar across all time points. In contrast, the mean scores of the other three groups decrease over time, more so for those in the exercise group and the diet and exercise group. Unfortunately, SPSS does not carry out pairwise comparisons to follow up the significant interaction. We therefore need to modify the repeated measures command in the syntax. Go to Analyze, General Linear Model, Repeated Measures. Our within subject factor of time is already defined from our previous analyses, so simply click the word Define. This will open up the Repeated Measures window. Everything that we previously put in here is already there. Instead of clicking OK like you did last time, this time click Paste. This will open up a new window in the syntax, which will include the command for repeated measures. You should edit the command by clicking at the end of where it says \em means equals tables bracket group asterisk time bracket. After clicking in that location, enter the text that is currently outlined in the red highlighted box. The highlighted box is there to draw your attention to what you should be typing. The highlighted box will not show up in your syntax, only the text that you type will. The information you have just typed in will compare separately for each time point the four group means. After you type this information in, hit Enter to create a new line between the line you just typed on and the line that begins with \print. In the line you have just created by hitting Enter, type the information that is outlined in the red box. Again, the highlighted red box is there simply to show you what information to type. The information you will type here will compare separately for each group the means across the four time points. Select the entire syntax wording and then hit the green play button located at the top panel. To answer question A, we need to go to the pairwise comparisons that compare each of the time points between the groups. We should put our focus on time point 1, which is the box at the top of the screen, and then look at the significance values for those in the box. As we can see here, P is not less than 0.05 in any of the differences between the groups, so there are no significant differences between groups at time point 1. To answer the second question, B, looking at the exercise and diet group only, are the changes across time and body fat percentage significant? We need to scroll down to the pairwise comparison table that lists each of the groups and then compares the different time points within that group. So let's shift our focus to the bottom of the table where it says diet and exercise. Looking at the diet and exercise section of the table, we can see that there are significant differences between each of the time points in the diet and exercise group. This is because the p-value is less than 0.05. When reporting in a text the results of a mixed design ANOVA test with one between subject factor and one within subject factor, you should present separately for each factor and their interaction, the F value, its degrees of freedom, and the probability value. The first number in your degrees of freedom comes from the line across the box in which your variable is. For example, for time, it would be 2 because that is the sphericity assumed number of degrees of freedom. The second number comes from the error within the whole box. In this instance, it would be 56. Be aware that if the sphericity assumption has been violated, you should report the epsilon adjusted, for example, greenhouse geyser, degrees of freedom, and the corresponding probability value. If the interaction is significant, do not interpret any further the main effects. Simply describe what the interaction plot demonstrates. If you have specific follow-up questions, report the answer to these questions. These answers can be obtained by carrying out the follow-up pairwise comparisons. These pairwise comparisons are the tests of simple effects and should not be confused with the pairwise comparisons that SPSS gives by default. If the interaction is not significant, focus your interpretation on the significant within and/or between subject effects. For each significant effect, explain which means differ significantly from the rest, e.g., the diet and exercise group had significantly lower body fat percentage than the diet-only and control groups. The results could also be presented in a figure or table format. A figure is easier for the reader to understand, especially when the interaction is significant. You can also present a table with the mean, scores, and standard deviations for each condition. Here we report the results in written format. We first report the main effect for time and the main effect for group. The interaction shows there was no significant differences between groups at baseline, and the control group did not change over time. However, the mean scores of the other three groups decreased over time, more so for those in the exercise group and the diet and exercise group. That is the end of the screencast on mixed design ANOVAs. In this screencast, we learned how to carry out and interpret a mixed design ANOVA test and how to report the results of a mixed design ANOVA test.